In the last video, we were just looking at a little bit of the when did life start on Earth. And we learned that although the Earth is around 4.5 billion years ago, and it was being hit by meteorites from around 4.1 until around 3.8 billion years ago, life seems to have started very shortly thereafter, at around 3.5 billion years old, maybe even a little bit earlier. So these might even overlap a bit. So all that to show that life started very shortly after it was bombarded. And since then, there's been life on Earth ever since. Now, that's talking about the when life started, but the question about how life started is much more difficult. And in fact, we're not entirely sure exactly how it happened, but there are some different sort of schools of thought related to this. So although I can't tell you exactly how life started on Earth, we're going to talk about three sort of key main ideas behind life starting on Earth. So one of them is called the rare Earth hypothesis. And it basically states that there's only life on Earth and nowhere else in the universe. In that sense, it makes us pretty special, doesn't it? Because, then there's no life anywhere else. This is the only place in the universe with life. And that may very well be the case. We're not sure. Again, remember, we only have one piece of data. We have Earth has life. Everywhere else, either know or don't know. We'd have to check every single planet around every single star in order to really know. So unfortunately, we don't know. So it is possible that the Earth is the only place in the universe that has life. And if there is no life anywhere else, well, as Carl Sagan pointed out in actually his book / movie, Contact. By the way, if you've never seen that one, that's maybe worth watching. That's a movie that's called Contact. But there, one of the characters in the story actually says, well, if there's no life anywhere else out there, it seems like an awfully big waste of space. So, if you're pessimistic, then maybe you think that the Earth is the only place with life on there. If that is the case, it still makes us very special, doesn't it? So that makes us really, really rare. And actually, it supports a paradox that a guy named Enrico Fermi, who is a very famous scientist and physicist, he actually explained this neat paradox. He basically said, well, it's so improbable, that life could form somewhere else that it probably only happened here. In other words, they're saying that the conditions for life are so tricky. It's so difficult to have life actually start that it's unlikely that it started anywhere else in the universe. So basically saying that that's the case. So that's called the rare Earth hypothesis. And it's actually opposite to something else. It's called the principle of mediocrity, where that states that, well, the Earth is pretty average, and as far as planets go, and it turns out, well, other than having life on it, but I mean its size and everything else, it seems pretty average, and it orbits around a pretty average star. And our star orbits, with many other stars, around a pretty average galaxy. So if everything is pretty average and we're not so special, then maybe life is also not so special. Maybe it happens in a lot of other places too. So that's the sort of competing argument for the rare Earth hypothesis. Remember, rare Earth says there's only life on Earth, nowhere else. That's what makes us really special. Now, what this Fermi paradox was all about, he was saying, well, just think about the opposite. And he said, all right, fine. I'll assume you have lots of other life out there. You know how we like to go and travel and explore things? So he said, fine, assuming that there's a whole bunch of other planets and there's a whole bunch of other smart alien civilizations that can travel around, shouldn't they have traveled to us by now? So that was his sort of paradox was, if aliens are so common, why haven't we heard from them? Civilization should expand, travel, visit, whatever, so we should have met them by now. So he said, because we haven't, that tells us that the rare Earth hypothesis may be true. So that's sort of what's related to this rare Earth hypothesis. It's a bit pessimistic, but it could be true. This might be the case. We don't know for sure. Next is something called abiogenesis. So that one right there, it's a really nice one. I think this is very, very interesting to read about this abiogenesis. And that's when basically you just need the right ingredients. You just need the right sort of recipe pieces, and then life will just start easily. Life will start spontaneously. So there was a famous experiment done by two scientists named Miller and Urey. Sometimes it's called the Miller-Urey experiment or the Urey-Miller experiment. So I'll talk about that. So that's Yuri Miller. And what they did, now it's a bit controversial because it was a bit flawed what they did, but it was a really neat idea. They basically said, all right, let's look at what we think the Earth was made of at the time when life first started on Earth. Let's take all those ingredients and put them in a jar, essentially. So there, for example, what they did is, they put those ingredients in a jar, added a spark, and let it be for a while. And it turns out then what they ended up getting was some sort of sludge in the bottom, because they did some really neat things with it. And it turned out that that ended up making a bunch of amino acids. Now, amino acids are found in humans and actually all life things. So doing this experiment, just starting with the raw ingredients, if you let them be with a spark and wait long enough, you end up with amino acids. Now, amino acids are part of things that are alive, but you can also have things that are not alive that have amino acids in them. So the fact that you have amino acids doesn't guarantee that that becomes something alive. You'd have to wait billions of years for evolution to take place and wait and see. So we don't yet know about this. We're going to talk about this one a little bit later. So in the next part, in part 3, we're going to talk about how do we look for life, and I'm going to expand on this experiment a little bit. But for right now, the idea behind abiogenesis is just that you need the right ingredients. If you have the right ingredients, then you can have life. So it basically says it's pretty common. You just need the right things in the recipe and away you go. And it actually states that the ingredients for life are everywhere. So you just need the right conditions. So maybe you need liquid water and things that we're going to talk about later. Now there is some support for this because it turns out these amino acids that make up life, they're found in comets. These things that are actually floating around in space, these, rocky, icy things that sort of, travel around the sun. So if this right here is the sun, let's say over here. Let's say that's the sun. And then you have a comet, let's say, that goes around. So maybe this comet goes like, back around like this and does like a big, circle and eventually comes back. Let's just say that that's what's going on there. So I'll just move this back. Well, these comets, it turns out, if you sort of look at a comet carefully, they actually contain amino acids themselves. In other words, some of the ingredients that make up humans and make up live things, so plants and animals, they all have amino acids in them. And so if comets have these materials, well then maybe that's going to support this abiogenesis. The idea that, well, all the ingredients are found everywhere, so why not have life also possible everywhere? You just need the right conditions, like not too hot, not too cold, all sorts of things. We're going to talk about those conditions in other videos in part 3. But for right now, I just want to mention abiogenesis quickly and say that it is one of these sort of schools of thought for what life might have done. So maybe you just needed the right ingredients. Another one, and this sounds even more crazy, it's called Panspermia. And what that one states is that, well, maybe life started elsewhere and it somehow migrated here. So maybe, alien life started somewhere else. That's what we call it, alien. And maybe it just made its way here somehow. Maybe it hitched a ride on a comet or an asteroid and there was some bacteria on it. And that bacteria then, sort of spread and ended up making other bacteria. And maybe that evolved into ... us, plus plants, plus everything else. And you might think this one sounds totally ridiculous, but it turns out there's some pretty strong evidence that shows that, well, panspermia at least is possible. So like I said, it may sound totally crazy, but it may have actually been the one that happened. The reason is that, small life, small bacteria, some scientists have said, fine, great, okay, whatever. But if you had small life that's over there, could it survive the journey? In other words, could it survive being out in space? First of all, because space is very harsh. It turns out, yes, some things can survive that. Then they said, fine, could alive things survive, entering our atmosphere when it gets really hot? Turns out, yes, they've tried that, and small bacteria can actually survive the journey. So there is actually evidence that does support some of this. It's going to actually be related to what we call extremophiles, and we're going to talk about that later as well. A lot of times it's written like this. So these are, organisms on Earth that we find that can survive in extreme conditions, so extremely hot or cold, or lots of radiation, or lots of whatever really weird situations, high pressure. We find organisms that can live in all sorts of crazy conditions. So if they can live in crazy conditions, maybe they were made somewhere else and then, hitched a ride somehow. They ended up on a comet that ran into us, or an asteroid, or whatever. So although it sounds totally crazy, it actually may very well be the one. At least it hasn't been ruled out. How's that? When we find the fact that life can survive these crazy conditions, at least it illuminates that maybe panspermia is at least possible. Nothing that says that it actually happened, but it at least is still possible. So all of this, I think, was a really interesting way to talk about how did we get here. So we did talk about the building blocks of life, how we're made of 4 of the 5 most abundant elements: hydrogen, carbon, nitrogen, and oxygen. But that's what makes up humans and actually everything that's alive, really. Plus other things, of course, but these are the main ones. We talked about how those were made. Those were made in stars, basically. How we define life, how there's difficulty in actually defining it. So we can use these 6 different definitions that we talked about. But each of them on their own doesn't work, but maybe in conjunction, maybe that makes life. We also talked about how life may have started on Earth. We learned about when it started. It started very shortly after late heavy bombardment. And since then, there's been lots of life in different ways, of course. And also we talked a little bit about the how. So instead of just the when, we talked about the how and talked about these 3 schools of thought, that maybe it's the rare earth, maybe life only exists on Earth, maybe you just need the right ingredients, or maybe it actually started somewhere else and made its way here. So that ends part 2. In the next series, we're going to talk about how do we actually look for life.